joining in. Hey Ritesh, thank you. Hello Vinit sir. So thanks everyone. Thanks Gopal Raju sir. Thank you. Vinit sir, Vinita ma'am, Anita ma'am. Yes. Okay. So we are going to begin. So let me share my screen. So in our previous sessions, we have completed our previous modules. Let me show that on Teachable. Right. Thank you so much. Sir. Hi sir. Okay. Let me know if my screen starts getting shared. Yes. Okay. So if you look at your Teachable, you'll be able to see that, in our previous sessions, we have slowly covered and progressed through our second module also. So we have completed our submodules of the first. Then we have completed statistics also. Confidence intervals, Bayesian statistics was our previous session. So I would request all of you to also go through the sprint by yourself, because it is more of similar exercises that we have completed in the session, right? So I request everyone to go through the sprint, which will be very resourceful in strengthening the concepts. Right. So today we are starting with the module 3.1, which is simple linear regression, right? So which is a part of the linear algebra, right? So how many of you have finished actually the linear algebra when Jain sir has taught? Ritesh says, I have. Okay, great. Thank you so much. Anyone else? I suppose maybe Vinita ma'am, you might have also finished. Okay, so that is great. So this is more of a revision actually. Okay, to all of you. So people who have joined recently need not worry. So all the pattern of these revision hackathons is in this way. So we are going to repeat or revise the concepts that are being taught by the primary faculty, which is Jain sir or Rajiv sir. So we're going to repeat or revise the same concepts. So if at all you've missed anything, there are two ways to access that. So you can begin from the... Yes.
Hi, good evening, Pramod this side. Basically, see, just I recently joined, in fact, in this week itself. So basically, from where I have to start and how basically I'm supposed to be started.
Sure. Okay, let me share that, sir. Actually, I was sharing the same. Thank you so much for the query and welcome to the community. Right.
Thank
so
you.
yeah, now, so basically, if you access your Teachable, so because you might have received the access to the Teachable, you will be able to navigate through the sessions. Like this is how your Teachable will look like, right? So you can start from the first lecture, which will be...
Yes. Basically, it's not getting open. See, once I start, it is means getting direct with the means mindset, resume, and all those things. But
okay, I think I got your answer. I request you to mute. Yeah. Okay. So now, how, if at all you have not received, so you're not able to see this, meaning you are in the orientation, because the lectures that you pointed out are in the orientation, right? So in your Teachable, you might have received 4 courses. Like if you log in your home, you will see orientation. Then there is this lecture, which is IIT Madras CCE and Pixeltest AI. Right. So when you click this, you'll be able to access these lectures. In orientation, you will see only orientation related content. Right.
Okay.
So you'd be required to go through this particular module, which is IIT Madras CCE and Pixeltest Artificial Intelligence. Right.
Okay.
Yeah. So then you'll be able to see all these modules. Can you see what all lectures can you see? Can you just let us know?
See, basically, means whatever I'm just studying, whenever I'm just going to connect, so I means unable to proceed with this.
Okay.
The means other things, just I'm getting it.
Sure. So what I'll do, Pramod sir, towards the end of the session, or maybe you can reach out. You can reach out to me, and I would be guiding you on how to access the right content. Right. So I'm just sharing the contact, right? So towards the end, if you're staying, that is fine, because this is like, between the module. So it will be kind of parachuting. You might want to choose to begin from the start, right? Just in case, if you want to stay towards the end, I'll be able to resolve your queries, sir. I'll assist you personally, right? So if there's anything also, if you're dropping, you can reach out. I've shared the contact. So that should be helpful, right? Okay. So anyone else who has joined recently, there will be one lecture which is called whole course, which is IIT Madras CCE and Pixeltest Artificial Intelligence. Right?
Yeah, basically, I have completed the orientation, Hall of Fame, interview mastery. So these three I have completed, and basically it was directing me again and again whenever I start. It is redirecting with that only. Then
I get it.
inner circle vault.
Yeah, so let me work with you, sir. I'll share towards the end of the session, help you on accessing the content. Okay, that should not be a problem.
Yeah, please.
Great, thank you so much, sir. Okay, so thanks for that, sir. So I will resume. Now, anybody who has joined recently, you can go through the whole content which is taught by the primary faculty here in this module 1.1, which is primarily taught by Jayan sir himself. So you can go ahead and access these lectures. Else, you can also access the recordings of the revision hackathons in your inner circle. Right. So some of our members are also doing this way. Watch module 1.1 or 1.2 of the primary faculty and watch the correct matching revision hackathon. So you can watch the actual lecture and revision hackathon, actual lecture and revision hackathon. So you can do in that particular fashion also. Right. So you can choose to remain in the same session, or you can join. Because we'll be doing this in a cyclic model, right? So once we finish from model the beginning towards the end, after that we are going to start from the beginning again, right? So this is how the structure of the hackathons is there, right? So in today's session we are going to cover the in the lecture, which is the module 3.1, simple linear regression. The collab file for the same is here. Okay, so let me also share that collab file link here on chat. Okay. So the people who have joined recently and you're choosing to, stay and also go through it. So let me, walk you through. So this link, once you open, it will ask you to sign in. And once you do that, you have to click on this particular connect option, right? So there'll be a connect button. When you click on it, it will start, right? So in today's session, we're going to learn what is the linear regression, and in that we're going to understand with a data set that is going to be helpful, right? So the objectives of this particular session is to create a scatter plot, right? So something that we have done previously, but now in context of linear regression. Now we'll also identify the independent and dependent variables when they are related to each other, right? So identify linear and non-linear relationships from a scatter plot, calculate and interpret linear correlation, right? So we'll also be able to calculate the slope and intercept of a simple linear line or a regression model also, right? So this is very simple, right? You might recollect your algebra days, right? So that should not be a problem, right? So then we'll predict a response from a simple linear regression model also. So people who have joined recently, do not be overwhelmed by these contents. You can go through the previous session and that will become more clear. And if at all you are continuing, just go through it on a brief overview perspective. Once you understand the previous concepts, this will become more clear. Great. Yeah, so Ritesh, we've scheduled roughly for an hour. Great. So now when we are trying to start with an example, like every time we are taking a data set, this particular data set, so let me show, which is called the long bones data set, right? So this particular data set has a few limited observations, which has columns, site, time, depth, lime, age, nitro, and oil. So let's try to understand what is this data set also, right? So basically, there were a few samples of long bones collected at a different depth, and their age, some of the age of those periods of those collected bones were noted down. The length, the time, and the composition of that particular bone was also mentioned. So we are trying to see if there's a relation between these individual elements, and we're also trying to see a few problems that that we are going to solve, right? So we are going to use the read_csv function to copy the data set into the data frame df, right? So you can go ahead and do df.head to see the first 5 observations. Okay, so let me go ahead and first clear all outputs, makes easier. So you can go ahead and see the head. Because it's a smaller data set, you can go ahead and see the whole data frame also. Right. So this is how the data frame is. You can see that a few elements have nans, which is the not a number or null element. So you can see that a few of them are there. So which might give a bias in the data. So we'll also see how to, we'll also try to remove these nans also, right? So which will give us, more specific data. So the two variables we are interested in, right? So is as below, which is nitro and time, right? So out of all these, we're going to be more looking into nitro and time, right? So these are the two variables we're going to work with. So nitro, what is nitro? The amount of nitrogen present in the bone of the skeleton measured in grams, right? So like in the whatever, for example, if it is 19, means 19 grams in 100 gram of bone, right? So that is how it is measured. Time is the interment time of the body, right? So basically how long it's been there. So the simple linear regression and correlation measure the linear relationship between these two quantitative variables. So let's go ahead and see what this actually means, right? So now what we're trying to do here is each of the two variables has a unique role in the relationship. There are two types of variables. That one is the dependent variable and the independent variable, right? So whenever whatever variable that we are trying to access, right? So or the unknown, which is also known as target, is a dependent variable, and the other variables which are used to predict changes in the dependent variable are called independent variables, right? So basically, which is unknown and which varies based upon a few set values is dependent, and which is by itself or independent is independent variable, right? So if you've understood dependent and independent variables, type U in the chat box. Yeah, thank you so much, Siddesh. Yes, so now Vinita ma'am, thank you, Ravindra sir. Thank you, Anita ma'am. Thank you, Gopal sir. So now, okay, Vinita ma'am says, why is the skip initial space equal to 2 and header equal to 0? And let me see. Okay, so basically, skip initial space. This is to clear out, the white space if there is any. I don't think that will affect the data set that we are trying to load in. So these are a few additional parameters that you can use to have a cleaner data set. So that should not be a problem, right? So if at all, whenever you want to understand anything, you can just hover onto that particular column, and it will give you a little bit more on that function. It will give you more details on the same, right? So I'm hovering here, so it's going to give a little bit more information, right? So it is more or less useful in trying to have a cleaner, if in Excel sheet, if you see, there is something called trim white space. So for example, if there's a number and towards, in before and after the number, if there is space, you will be able to remove that. So here the skip initial space works in a similar fashion, right? So now header equal to 0. I'd also come back here. So what this means is like whenever you're importing an CSV file, you're telling if there is a header or the title in the sheet or not, right? So I think that is what is there. When you do not give this, by default they are true or 0, right? So that should not be a problem. Okay, now what we're trying to do here is, give me a second. So is my audio clear? Type A if audio is clear. Okay, great. Okay, thank you so much. So now what we're trying to do is, in all of these, we're trying to first go ahead and visualize this, right? So if at all we want to plot a graph and try to know how this data is scattered, right? So we're going to do a scatter plot here. So let me go ahead and do that. So how do we do that? We're going to import the library matplotlib.pyplot. So people who have joined just today, if at all you are planning to see, we have explained this clearly in our previous sessions. So this is how you are able to use a few functions that are not defined here, right? So we are going to use the alias sns.lmplot, and we are giving the input as the data frame that we have created above, the axis X and Y as nitro and time, right? So the CI here is confidence interval. So let me first plot it and show it to you. Right. So what happens here is, so when you do this LM plot, what is going to happen is, it is going to give you a scatter plot with, you can see the X label here is long bone nitrogen composition, which is given here, and the Y label is interment time in years, right? So you can see that the data is scattered, and you can all there is some relation, right? So there is some relation where if the, let's just say the composition, the nitrogen composition is higher and the intermittent time is lesser. So there should be some relation here. Maybe you can predict something, you might not be right, but there is some relation here, right? So now if you see this particular fit underscore regression reg is false here, right? So in the LM plot, when you make this true, we'll also come across this. You will be able to see one line that goes through that particular plot. So this particular line is the most the closest line towards all the points, right? So it is not actual line, but it is showing you there is a relation between the long bone nitrogen composition and the time in years, right? So basically, as the nitrogen composition is increasing, the the intermittent time that is there is lesser, right? So there is some relation, right? So how many of you are able to see that there is some relation when you're trying to plot nitro and time together in the graph, right? So if you're able to see that there is some relation, type C in the chat box. Great. Okay. So I'm going to thank you so much, Sudesh. So now we have scattered, we did the scatter plot, and we have understood this is how the dots are plotted, right? So it is similarly, so people who have just joined, so not worry here. Let's say if you have seen the graph here, and if you're just having nitro and time together, let's just say when the nitro is 3.88, the time is 88.5. So you're going to say, when the nitro is 3.88, the time is 88.5, and there is one dot here, right? So all those plots are getting plotted here, and the best thing in Python is there are a few libraries which will help you plot that automatically. You do not have to do it manually, right? So this is how we have done it. And there is some relation. So we'll try to get in depth towards that particular relation. So from this scatter plot, we can see that there is maybe a negative relationship between the amount of nitrogen still remaining in the long bones of the skeleton and the length of the time the skeleton has been buried. So why we are saying negative relationship is because if you see the slope of that particular line, right, which is negative, so it is going down, which means as one element is increasing, the other is decreasing. So that is why it is negative. So for example, if it were like this, right? So the positive slope, as nitrogen was increasing, the time was also increasing. So that relation would have been positive, right? So now here the relationship is negative. I hope that is clear. Right. So now what we are going to do is we are going to take a shorter data. We are going to just have a look at the data set. And this is what we have already looked at. The age of individual at the time of death was unknown in several cases, meaning there are NaN values here. Right. So what we are going to do is we're going to clear those NaN values. So how do we know how many null values or NaN values are there? So we use the isNull function, which we have done previously, right? So in our previous sessions, we have seen in the data frame, if you're going to use the dot notation and say isNull, it is going to give us the number of nulls that has. And when you do one sum, so let me just go ahead and do it. So when you do a dot particular, so let me comment this. So when you're going to do first one dot sum, it is going to give how many nulls are there in each column, right? So age has 7 nulls and depth has 1 null, right? So when you do another dot sum, so it is going to give you a total like 7 plus 1, 8. So you have 8 null values. And how do we remove that null values? So we are going to use the drop NA function. So whenever you create a new data frame and say df.drop NA, so it is going to drop all of the observations where we have null rows, right? So null records, right? So that is clear. So now we can see that when we use the data frame.shape, it is going to give us the rows and columns in it. So we have 7 columns and 42 rows here, right? So we've already done this. Let me see if this is a different graph. I think this is the same graph. Okay, so what we have done alternatively here is we use the hue, right? So if you remember the hue, whenever you give another column name, what happens is those get identified and colored differently, right? So here, one thing that was identified is whenever the oil was 1, the age was NaN, right? So what we have done is we tried removing those observations. So before removing, we just plotted them here by saying hue equal to oil. So wherever there is oil equal to 1, that will be plotted in a different color, where oil is equal to 0 will remain in the same color, right? So hue, we have when we did the SNS module, we have understood hue in a very detailed way. For example, if you're looking at the Titanic example, hue gave us different colors for different classes or different genders. So that is how hue becomes useful. So we have seen that these 3 points we are going to get rid of because the age there is null, right? So how do we do that? We use the drop NA. When we are doing the drop NA, before dropping, the number of observations were 42, and after dropping, the number of observations is 35, right? So, and the new data frame right now is long bones. So we're going to use long bones data frame, which is a cleaner data set, right? So how did we get the length? We got using the length function, and we have passed in the data frame as an input to get the observations length, right? So now we are here, we are a cleaner data set. So how many of you are clear till now that we got a cleaner data set? If you are clear, type C in the chat box. Thank you, Ritesh. Thank you, Anita ma'am. So now what we are going to do in the same set here is, let's look the scatter plot of the same, right? So we are going to plot it. Now those three observations, especially the hue oil is gone, right? It's no more, right? So it's all zero observations only, right? So we have a cleaner data set. Now we'll just try to understand, we'll quantify the relation. So what we have done is we have understood that there is some correlation between, which is a negative correlation, which is some insight that we have got. But if we can have a number associated to that particular relation, then you can, compare other aspects also. So with Python, we'll be able to quantify that relation also. So we'll see how do we interpret that linear correlation, right? So now what we're trying to do here is first try to understand. So when there is a value which is called the linear correlation coefficient, right? So which means, give me a second. Yeah. So now linear correlation coefficient R is going to be helpful for us to know how related those two columns or values are. Right. So this measures the strength and direction of the linear relationship between two quantitative variables. Right. So this has to be clear because this is what we're going to be useful. We are going to use. So now correlation is measured on a scale of -1 to 1. -1 is perfect negative correlation, right? And 1 is perfect positive correlation, right? So we have understood what is negative correlation and positive correlation, right? So that is there. And 0 is no correlation. There is no correlation. Whenever you can see that there is no linear, so either it is non-linear or there's no linear correlation, then the linear correlation coefficient will be 0, right? So then correlation has no units. It is just a coefficient, it's just a value. The correlation of x with y is equal to the correlation of y with x, right? So that is something, the R value for x and y and x will be same. Now, if we take the positive value of the correlation, when we use the modulus of R, if that particular correlation, the value is greater than 0.80, it is considered as a strong correlation. So if it is, let's just say minus 0.80, if it is over minus 0.80, it is going to be a strong negative correlation. If it is going to be plus 0.80, it's a strong, positive correlation, right? So no matter the positive or negative, if it is higher than 0.80, then it is a strong correlation. If it is lesser than 0.20, it is considered a weak correlation. So these are a few properties of the linear correlation coefficient, right? So there are manual ways to identify how to, the R value, but Python makes our lives easier. So there is a function. The name of the function is Pearson R. Now we are importing the scipy.stats module here as st, right? So this particular function Pearson R takes the data set, the columns nitro and time as input, right? So you're going to give the columns in which you want to know the relationship, right? So now you understood there's a negative correlationship. Now you want R value. So how do we get that? You say, I want the correlation coefficient for the nitro column and time column in the data set long bounds. So when you do that, the output of this Pearson R will be saved in two particular, the output will be two variables, two values, and that values we are saving in R and P underscore value, right? So here, if I'm going to print it, now you can see that R value is minus 0.67, right? So which means we have known that minus signifies it's a negative correlation, and it is less than 0.80. So it is like, not a strong correlation, right? So strong correlation. So how do you know if it's a strong correlation? If all these dots scattered, if they are closer to a line, right? So like if they are like perfectly in a single line, there is a strong correlation, right? So what that will help is, so for example, I'm going to say here true. and I'm going to show it to you. So now if you see all these dots are coming on the same line, there's a strong correlation. What that means is, let's just say if there is a missing value also, let's say we want to know what is the intermittent time in years when the nitrogen is 3.5. So you'll be able to plot from the graph itself, plot over the line, right? So 3.5 is here, and for 3.5 the value is this, and because the equation of the line or the line is known, you'll be able to easily with 100% confidence tell that this is the time for so and so nitrogen. But here the correlation, because it is scattered, there is not a strong correlation, right? So a strong correlation meaning the dots will be closer to the line, right? So I hope this is clear. So if this is clear, type C in the chat box. Great, thank you, Vinitha. So now we've understood a few properties. Thank you, Ritesh. Thank you, Ravindra sir. So now we've understood the properties of the correlation, the linear correlation coefficient, and we've also used the formula or the function Pearson R to get the R value, right? So the P value is not needed for us here because we are trying to assess it. So basically there are many other values that come, like if you remember in our previous sessions also, we are more concerned about one of the variables, but if at all you want to know more about it, you can always hover on that function, or you can go deeper by searching more and understand, because here the scope is only to understand R. We have got it. So now this is using pandas, right? So we are using the import. We have imported stats from SciPy. We have done this, but if at all you want to do the same using a NumPy import, right? So for NumPy also there is a function which will directly give us the same correlation coefficient. So the name of the function is CORR-COEF. It's basically shorthand for correlation coefficient, right? So similarly here input you are giving nitro column and time column, and it will directly give you the correlation coefficient. Now if it is giving multiple outputs, right? So I'm going to run here. So now you can see that it has given the same value, which is minus 0.67. Here the method is different, that's it, right? So if you want to use this SciPy library or module, or you want to do it with NumPys, you can go ahead and do it, right? Two ways we have got our coefficient. So we are a little closer in our journey to understand the relationship between two, right? From the beginning till now, we've understood that there was a data set. And after a little assessment, we came to know that there is some relation. Then we cleaned the data set. Then we understood there is a negative correlation. Then we plotted a graph. Then we, also understood more about it. And then we got a value specifically telling us how much is the correlation, right? So till here, we are clear on how and where we are. So let us try to understand more about it. So now, this correlation coefficient gives us more information than we actually know or need for now. So right now it is telling us the correlation between X and X is 1. So basically the correlation between the same column with the same column is always going to be 1, right? So X and X is 1 and Y is 1, right? So the correlation between X and Y, which is what we are interested in, is minus 0.67, and the correlation between Y and X is also going to be the same. Later on, we'll calculate the correlation between multiple variables. Like, while we go forward, because we are in the simple regression right now, we're going to understand the correlation between two columns right now. But as we proceed forward, we are going to also understand, matrix type of correlation also, right? So this, this suffices to say that the linear correlation between nitrogen composition and the time is minus 6.07. But this does not quite qualify as a strong correlation because the mod R is less than 0.80, right? But it's not a weak correlation because it is not less than, it is between 0.20 and 80, right? So we can say it is moderate correlation, right? So if you understood what is correlation and how did we find it, type U in the chat box. Great. Okay. Thank you so much, Ritesh. Thank you, Anita ma'am. Now let us try to understand different types of correlation. So this was one data set that we had and we got the correlation. Now let's say if we have this plot, right? So if you remember, I was trying to explain the same here. If all these dots are going to be on a single line, it is going to be a strong correlation, right? Thank you, Raja sir. Thank you, Vinita ma'am. So now let's say this is a plot. This is like a diagrammatic view, but let's just say there's a data set and the plot came like this. Now the slope is negative, meaning with the increasing of one variable, other is decreasing, right? So what is happening here? All of them are aligned, meaning there's a negative correlation, and because there's no scattering here, it is a strong correlation. So both the column A, like the X and the X and Y are strongly related, in a negative way, right? So here there's a very strong positive correlation, right? So this A and D, we are clear about this. Now let's just say this was one of the case, like something simpler. If they are scattered away from the line, like this is if we do the fit underscore regression equal to true line, the line will come here, but there'll be a few points here and there. So still it is negative correlation, but it is not strong. So it's not -1. So it is minus 0.9794. Okay. So this is a random example. And let's just say if it is a little more scattered, the correlation is going to change, right? And there would be some columns that you are trying to compare, and there's no specific relation there, right? So now if you see here, there's no specific relation. So you cannot, there's no linearity, right? So it's going to be something else. So for that, there'll be 0.08, right? So it is very less. There's very little correlation. And if you have a fancy graph like this, which is not at all linear, there's no point which is in alignment with other, right? So here at least 0.08, there might be, if there's one line that goes here, 2 or 3 points might be closer to that line. But if here in this particular example, you cannot have one single linear. So if you remember, simple linear regression, right? There's no linear relation between those two columns. There could be some other relation, or there might not be, but there's no linear relation between those two variables, right? So if you understood this, like if you understood different time, yes, Ravindra sir, there's a perfect correlation. So now if you see here, they are all on a line, there's a perfect correlation. You're right, Ravindra sir. And we tried we tried to understand the same here. If the correlation is -1, it is perfect negative correlation. 1 is perfect positive correlation. You are right on track. Okay. The F should be negative. So is there a question? No, there's no correlation. So here R equal to 0, the coefficient, the value, the R value, the correlation coefficient here is 0. You cannot see there is, there cannot be a single linear line that can go here, right? So Vinita ma'am, yeah, so this is the F1, this is the C1. So you're talking about the C1, I guess. Yeah, so here, now, if let's just say there is two data in the data set, there are two columns. Now you can see that if the scattering is like this, there might be a line that comes through it, where let's say if you see these 2 points or these points are closer. So there could be a line that could go through that, right? So here, okay, so sorry if my cursor being like this confused you for it being a negative. So what I meant is there is a very little correlation here, right? So it is positive, like here it is mentioned positive, which is just for an example sake. Vinita ma'am, I think I understood your confusion when I say like this. You thought it is a negative correlation, right? So Nothing like that. So it is very little correlation. It is almost zero, like 0.08, right? So it's almost zero. Almost there's no correlation. I hope that clears the query, ma'am. So now, yeah. So let's say if the graph would have been here like this, right? So my point was that it's no correlation or less correlation. Yes. Ravindra sir, you say M. Is there anything specific you wanted to say, sir? Okay. Okay. Great. So now we have understood this, and this has been deeply explained here. Like for example, like these are the plots. Let's just say these green points are the plots, and this particular line, the simple linear regression equation, meaning the simple linear regression line, is the closest to all these points, right? So this particular plot, it is going to be the closest line, and this particular line is called estimated regression line. Yes, Rajamurthy sir, you are right. And I think that also answers your question also, right? So it is only for linear relations, right? So that is what we are trying to assess here, sir. Like when there is no linearity, we are not able to assess the relation. Thank you so much for adding in that, sir. Now, so for example, if these green dots are the actual points, now when you are doing the estimated regression line, here you are going to have a predicted response, right? You know, basically, let's just say there's this one point which is, let's say, on x-axis, which is 5, right? So this is going to be 5, x equal to 5, and y equal to, say, 0, right? So y equal to 5 and x equal to 0, right? So now you can see here, but the other points are already there, and the linear regression line will try to make an estimate and try to make a line out of it. So that is how you find the estimated regression line, right? So all these areas also, even when we say true. So now this line is the estimated regression line. The actual points are this, right? So now, because this is an estimate, the actual points are different. For example, if this is the point and this is the estimate, so it has made an estimate for that will be aligned to all of the plots, and the difference between the estimated value and the actual value is known as residue, right? So this is what is called the residual, right? So now if, for example, there was the actual point was here, but to make the estimated regression line, the predicted response was plotted here. Okay, so the difference between the actual and the estimated is known as residual. So you can see that this, the gray dotted dashed line, this particular length or difference between the actual and the estimate is called residual, right? So if you understood what is the estimated line and what is the actual response and what is the predicted response, and the difference of that is called residual. If you understood these points, type U in the chat box. Thank you, Vinitha. Thank you, Titesh. Great. So this is what is there. And if at all, you can also try to, thank you, Ravindra sir. Thank you, Raja sir. You can also generate the residual also here. If at all at any point of time you wanted to understand what the residual, you'll be able to also generate that. So what we are going to do here is, so in the actual session also, sir gives us an example, right? So let's just say this point was, say, 5 and the actual was 5, and for the plot it was 3. The residual here is 5 minus 3, which will be 2, right? So similarly, sir explains in the actual lecture also, right? So now what we are going to do is, coming to our objectives back, we're going to calculate and interpret the slope and the intercept of a simple linear regression model, right? So now this in general is a very easy process, calculating the slope and intercept, right? So I'm also going to share with you a sheet, and I'm going to show you, like, in general, how do we calculate this particular equation, right? So now, whenever you wanted to find slope is basically, y by x, right? Y by x is, if there is the difference. Okay, let me show it here. Now, this particular equation, like, say there's this one point, which is, let's say 20 on y and 25 on x, right? Yeah, so Pramod sir, basically there is a whole process for installing the Python. So the Pramod sir's question is how to install Python. So do not worry right now, because this is your initial lectures. You need not actually install Python on your system. There are ways to install also. Here we are working with something called Google Colab, right? So once you have access to your Teachable, in that first lecture, we show you how to work with Colab, right? So when I'm going to, towards the end, I'm going to assist you. There you'll be able to easily, work with this. I'm going to help you out.
Okay, right.
Yeah, thank you. So now, so how do you know? So now let's just say here, if at all you wanted to know the, the slope, it would be, y by x, right? So this is how you do. But for this particular line, this is not passing from 0. Like, say it is starting, this particular line, it is starting from 0.5, right? So now, how do you do that? If you wanted to find a slope, the equation is y minus y naught. Okay, so I'm going to say Anaconda 3 can be used for Python if you wish to install Python on your laptop. Yes, thank you so much, Rath. I'm going to guide Pramod sir also. So similarly, x minus x naught, right? So basically, y naught and x naught are the initial points from where we are trying to calculate. For example, if at all you wanted to know, let's say, let's assume that this point is 20 on y and 25 on x. So y is 20 minus y naught. So let's say it is starting from here and say it is 5, right? So 20 minus 5 would be 15 by x minus x naught. So the x value here is, let's say, 25, and x naught is being 0. So you're going to say it is going to 15 by 25, right? Yes, I think Raja sir, if at all you have the link handy, you can even share that. Okay, so this is how you find the slope in a regular scenario, in a mathematical way. But now we have x naught is 0. Now, if you see this particular point, here we have the equation. So I think x naught is 0 and y is 5, right? So I think that should be clear, Vinita ma'am. Yeah. So this is like a normal slope calculation. So m is always going to be the slope here, and b here, or the intercept. Intercept is basically the line, basically where the point where the line touches y-axis. So here it is touching at 5, right? So this particular point is 0, 5. Okay, so now you can see that 0, 5 and 5 is the intercept. So if at all you have a line and you want to calculate in slope, it is y by x, or y minus y naught by x minus x naught. And the intercept is where the point touches the y-axis, right? So why do we say simply it is y by x in many cases is if the line passes through the origin, the y0 and x0 becomes 0 and the slope becomes y by x, right? So the intercept, which is also known as C, is, let's say if it is 0 comma C, let's say if it is 0 comma y, is the point, and this intercept C equal to y, right? So the point on y axis where the line touches, right? So the linear regression line touches the axis, right? Right, so this is the intercept. This is how we normally manually calculate. Sir also explains that in the session. But if at all we want to try to do it here, so how do we do that, right? So let's go ahead and do the same here. So what we are trying to import here is to calculate the linear regression model, we need to import a new package and get the data in the correct format. And we are going to import from statsmodels.formula.api. Right, so you might want to, maybe the formulas also you might you might not have to recollect, but you might want to remember the names of the modules because they become helpful, right? So they are always helpful. So from this particular module, we are going to import OLS, right? So now OLS is the function that is going to give us more values, the required values, right? So I'm going to hover on OLS, right? So you can see all the values or all the details mentioned here, right? Now, the equation is very simple when you import the OLS. It is the column time, which is the y-axis, and tilde. The sign here is not minus, right? So if I zoom in, so you can see that this is this tilde sign. So the equation is going to be time tilde nitro. So when you specify like this, the equation, that input goes into the OLS function. So I'm going to generate the model equal to OLS, and the equation is y tilde x. So basically the relation of y with x and the data set long bones, right? So I'm going to use the subfunction dot fit, and it is going to give me two outputs, which is 0 and 1. So I'm going to try to print them. Now you can see that the first parameter was 316.8 and then minus 69.2, right? So now this, what we tried manually doing here with the help of the function OLS and with the help of this particular equation, which is y tilde x, you got the equation of that particular line, which is y equal to mx. So here the second parameter, second output is the slope, which is minus 69.24, and the intercept here is 316.8, right? So this is how you were able to generate the equation for the line and also calculate the slope and the intercept of it, right? So let us go here back and try to understand it clearly. Right. So now here on the same slope equal to model dot params. Now this particular parameter, the second parameter, which is at index 1, is the slope. And if at all you want to write it in a better format, we are just going to use the same nomenclature and text here. So long bone nitrogen composition, this is on the x, and on y it is intermittent time in years. So we are going to print, we expect that we're going to round the slope and going to print the y unit. So I'm going to just run it. So we accept that minus 69.24 intermittent time in years will result from a single unit of long bone nitrogen composition in grams per 100 gram of bone, right? Basically it is the slope, right? So that is how we have found the slope and intercept of that particular equation, right? So how do you make the meaning out of this particular equation? The slope tells us the expected change in y for 1 unit change in x, right? So basically the slope, that is the definition of the slope, right? So for every change in y, what is the change in x, like, what is the 1 unit change in x is given by slope. The intercept tells us the expected value of y when x is 0, right? So when 0 comma y, right? So this is what the meaning of that particular line, right? So now what we have done here is we had a data set, and out of that data set we have cleaned and we tried getting the relation out of that. What is the a relation? We have understood there's a negative correlation. We have cleaned the data set, and then we have also formulated and got to one specific value to that particular relation, which is the linear correlation coefficient. Okay, so was it here, ma'am? Is it, Vinita ma'am, is this where you want me to repeat? Yeah, slope and the change. Okay. So basically, now whenever you look at any slope, right? For example, this is the slope. So now what is slope is basically delta y by delta x, right? So I'm going to say, show image. So now if you look at any particular line of slope, yeah, so this is easy, right? So basically it says some easy ways to, yeah. So I request, so basically slope is rise, basically y by run, right? So rise by run. So now what slope signifies is with every unit change of y, right? So whenever a y is changing, how much the x is going to change, right? So basically the slope is going to be that, right? For example, any equation you see, so with every unit change of y, what is the unit change of x? So basically, for example, if the slope is 2, let's say, I'm just going to say if the slope is 2, let's see if we are going to get a slope equal to 2. Let me see if we have an equation of slope equal to 2. So basically, okay, so when you know the slope is equal to 2, for every unit change of y, okay, I'm going to show it here. Okay, let's say m equal to 2. The slope is 2. Now I'm going to say x comma y. Okay, so now the equation is y equal to mx plus c, right? Now let's say we have the equation, the slope is 2, and I'm going to say the intercept is going to be 0 here. Like, let's assume the intercept is 0 in any particular point, right? So now what is going to happen is, you can see that for every unit change the slope, for example, if x is going to be 1, y is going to be twice of it, right? So every time, right? Almost, I'm just going to give you the delta change here. So whenever the slope is going to be 2, for every value, if it is 1 comma 1, so if the x is 1, y is roughly going to be 2 plus c, right? So 2 plus c, and if it is going to be 2, it's going to be updated, so it will be twice roughly. So here, if I try to understand, the slope tells us the expected change in y for 1 unit change in x. So whenever there is a specific change in x, the expected change in y could be told with the help of slope. So it is essentially the same slope, right? But it also gives you an understanding of how much rise is happening with 1 unit of run, right? So that is what is slope, right? dy by dx. Thank you so much, sir. I hope, Vinita ma'am, that is clear. So you can just try to simplify it like so. With little of run. So which one unit of run, how much change is going to be in y. So the slope gives you an estimate or understanding of that, right? I hope that becomes a little clearer, ma'am. Yeah, so is that clear, ma'am? Can we proceed? Thank you, Raja sir. Right, so basically we clean the data, and then we have understood the value for roughly, because there's also the intercept portion, but it gives you correct estimate, ma'am. Correct. Because the C portion is also there. So it is giving you the expected change. It is not going to give you the expected value. It is going to give you the expected, like how Raja sir mentioned, it is the change in Y, right? So it is going to give you the expected change, right? It's not going to give you the exact. So it's basically, when you put values in sentences, this is how it goes, right? So I'm just going to reiterate. So we found the equation, we found the line. Here we have understood that, there is some correlation, and what is the value of the correlation also we have understood. But we have not understood the equation of that particular line. So to get the equation of that particular line, we use this particular function, which is the OLS function, and we give into that the equation y minus x, and then you are going to generate the slope and also the intercept, right? So you're going to generate both of them here. So here y equal to mx, m here is minus 69.24, and c it's basically is listed out here, right? So this is how you can go ahead and get the equation of it. So it's not going to be the same line as we normally do. So the equations could be different, but you're with the help of this OLS and these two parameters, you're going to generate the equation, right? So I hope how do we generate the equation is clear. If Vinitha, if there is a little confusion on the definition for slope and intercept here in this context, I think if you're understanding slope and intercept, I think that is also good enough, right? So this is how we have derived or come to the point where we have got the equation also, right? So similarly, I think we have done this previously also. When the fit underscore regression is true, you get the line, right? So when it is false above, it is going to be just scattered plots, right? So we have understood till here how to find the equation. So because we want to keep our sessions specific to 1 hour, we are going to just take the objectives of predicting the response and calculating the residual, which would conclude the session. We are going to take this up in our next session along with the module 3.2, right? So I request, because the aim of hackathons is to clear or help you progress through the course. If at all you have finished 3.1, you can go ahead and finish the sprint or quiz for the same. If at all you have understood 3.1 here, if you've recently joined, even if you understood briefly, you can either go ahead, start from the beginning, or if you already finished, you can go ahead and finish 3.2 before our next or tomorrow's session, right? I hope today's session was clear in terms of understanding of how to get the the correlation between two particular components. So if you understood that particular portion, you've justified today's time, and tomorrow we're going to understand the module 3.2, right? So if there's any query, you can put it in the chat or ask us. If there is anything else, if everything else is clear, type C in the chat box. Thank you, Radhaska. Thank you, Ritesh. Okay. Thank you, Vinitha, ma'am. Thank you, Vinitha. So even if you want to go through James's lecture also, you know where to find it. It is going to be in the 3.2. Okay. So thanks everyone. We're going to conclude today's session here. And in our app, I request you to go ahead and do the assignment, right? Thank you so much, Ravindra sir. Thank you, Raju sir. Thank you, Vinit sir. Great. And I request people who have completed, the session, you can safely drop the call. I'm going to just take a few queries of the other participants. Thank you, Ritesh.